All right, welcome back. And today we're going to talk a little bit about atoms, elements, ions, isotopes, and a little bit about chemical bonding. So it's going to be really, um, not a really involved, but just a little description of things. So a lot of this you should have learned in middle school, right? So the atom's a basic form of matter. So if I take anything apart, right? So if I take you apart, or me apart, or my dog apart, eventually, if I just kept taking it apart more and more, I'd get to atoms. So everything's made of atoms, and atoms are bonded together, and bonds are made of electrons. Okay, so if we look at the periodic table of elements, right? There's a little line here that comes across the periodic table right here. So everything over on this side is metal, and everything on this side of the stairs is non-metal. Right? So everything's a metal and non-metal. Right? So if I take out this little group in the middle, right? These are transition metals. So really I'm going to concentrate this lecture on aluminum and these two groups right here. And those atoms right here. So these are what are called main group elements. Because their properties are kind of simple and they don't really vary. The transition metals vary a little bit because they can have multiple charges and whatnot. So we're gonna concentrate mostly on the main group elements. All right. So the human body, we're made mostly of carbon, hydrogen, oxygen. Oops. We'll keep with our pink theme. Oxygen, nitrogen, and phosphorus. Right? So those 5 elements probably make up about 90% of your body, right? Carbon, hydrogen, oxygen, nitrogen, and phosphorus. But you need some other molecules in your body or some other elements in your body, right, in order to function well. You need sodium, magnesium, calcium, potassium. So there's some elements that you need, right? Because they help you with charges. You need chloride ions in your body, right? So we'll talk about a lot of that kind of stuff. All right, so moving forward, so we're going to concentrate on these groups, and the reason why we're concentrating on those main groups is that's pretty much mostly what you're made of. Right? So let's move on. So atoms are made of subatomic particles, right? You probably remember this all the way from elementary school. Okay. Subatomic particles. Protons are found in the nucleus and give it its charge. The atomic number, right, is a proton. So if you look at the periodic table again, hydrogen is 1, it means it has 1 proton. Helium over here on the other side is 2, it means it has 2 protons. That number on top is the number of protons. All right, so protons give an atom its properties. A proton has a positive charge. It has a mass of 1 atomic mass unit. And most importantly, it cannot be changed. Right? So if we look at, for instance, carbon, right? Carbon 6, right? It means that it has 6 protons. All right? So it has 6 protons. If I gave it another proton, it would have 7. It wouldn't be carbon anymore. If it was 7, it would be nitrogen right next to carbon. Neutrons are also found in the nucleus, and they determine the isotope. So we'll talk about isotopes. So atoms can have different numbers of neutrons, right? But if it doesn't have the right amount, it tends to make it radioactive. So neutrons determine isotopes. So mostly carbon is 12, right? So this 12 is neutrons plus protons. That's why it's the number 12. So if it's 12, it has 6 neutrons and 6 protons. So sometimes we do like this, carbon 12. That's called isotope notation. I could have carbon 14, right? So that's a radioactive isotope we use for radioactive dating of things that have been dead a long time. So this 14 means that it still has 6 protons, right? It has 6 protons because carbon always has 6. If it has 6 protons, it would have to have 6 neutrons. So neutrons often I do with positive and negative charge because a neutron does actually have both charges in it, which makes it neutral, and that's why it's called a neutron. It also has a mass of 1 AMU, or atomic mass unit. Right, so these are 2 isotopes, but the important thing to remember is both of them have to have 6 protons, because protons determine what an atom is. All right, so electrons are next. Kind of did that funny, sorry. So electrons are right here. So electrons are found around the nucleus in clouds or cloud densities. We used to call them orbitals, but they don't really orbit like a planet around the sun. They're just kind of going back and forth. So if I take something like helium, right? So helium has 2 protons, has 2 neutrons in the nucleus. It has atomic mass of 4. And around it, it has 2 electrons. And those electrons are vibrating back and forth. And they're always moving, right? So oftentimes we try to picture an orbital being a circle. That orbital just defines how far the electrons can travel. But the electrons are just vibrating and constantly moving. They can be lost or gained to form ions. So an ion, right, is a charged atom. Right? So electrons have a negative charge. So oftentimes you'll see electrons shorthand like that. So they have a negative charge. So if I gain an electron, or let me put it this way. So metals lose valence electrons. Valence electrons are just outer electrons, right? And they have a positive charge. Because electrons are negative charged, so if I lose an electron, I'll have an overall positive charge because I still have protons in the nucleus, and protons have positive. So if I take sodium, which has 11 protons, right? If sodium loses an electron, right? So sodium loses an electron, then it now has 11 protons and 10 electrons, right? So if I take this, I'll have 1 positive charge left over. So this sodium now, I would write with a positive charge, right? And those are going to be called cations, right? So nonmetals can gain valence electrons to form anions, right? Same color, they'll form anions. With a negative charge. So let's say I have chlorine. I have chlorine. Chlorine has 17 protons, right? So chlorine takes this electron from sodium, right? So now chlorine would have 17 protons and would have 18 electrons, right? So it would have 1 extra negative charge because it has more negative and positive. And we would write that now as chlorine with a negative charge. Okay, so you don't have to be an expert at this, but we need to talk about this because the body uses these charged ions to communicate between cells. Right, so it's going to be important. So if you remember, I told you before, we have this break here. It just comes out that way, right? So all my metals were this way, and all my non-metals were that way. So everything over in this side will lose electrons. And everything on this side will gain electrons. The exception is these noble gases at the very end here. These noble gases, right? Their valence electrons are full, so they won't lose or gain anything, right? So they don't form ions. So the noble gases don't form ions. Okay, so those are the exception to the rule. All right. So we'll talk a little bit about bonding. Now I've given you a periodic table, so it might be a good idea. So let me clean this up a little bit, because I'm going to tell you what to do. Let me just clean this up a little bit. All right, so the periodic table, things you should know. So metals will lose their valence electrons. Those are electrons in the outermost orbital. So for instance, two that we use a lot, hydrogen. You'll see that this says group 1 over here. So group 1. So group 1 has one valence electron. So there's a thing called the Lewis dot method. And Lewis dot will write the valence electron. So hydrogen will have one dot. Sodium will have one dot. So these will all lose one electron, and they'll form a 1 positive charge. Right, so everything in that group 1, that vertical group, will lose that. If we look at the next group, group 2, right, so I have group 2 here. So group 2 has 2 valence electrons. So if we look at some of the things in group 2, magnesium, we use magnesium in our body a lot. We use calcium in our body a lot. Right, and if we wrote those with the Lewis dot method, I'd get 2 dots. And these dots represent the valence electrons. Right? The reason why I put them far apart is because electrons repel each other, so they want to be as far away from each other as possible. So these will both lose both their electrons, and they'll make a 2 positive charge because they're in that group 2. The main group element that I'll give you an example for over here is aluminum, right? So this 13 is really group 3, 4, 5, 6, 7, 8. So there's an old, so the new is 1 through 16 or 1 through 18, but the main group you can label 1, 2, 3, 4, 5, 6, 7, 8. Right, because we're going to take out the transition metals in the middle. So aluminum, if we wrote aluminum in group 3, we have 1, 2, 3 valence electrons. So aluminum would form a 3 positive. So remember, other atoms we're interested in, we have carbon, nitrogen, oxygen, chlorine, right? Those are ones we're interested in. So chlorine is a nonmetal, right? So our carbon is a nonmetal. So we'll do carbon. Carbon has 4. 1, 2, 3, 4. Now carbon will not lose electrons, right? Carbon will want to gain electrons. So it has to gain 4 electrons to make itself stable, because it has to get to 8. Right? So it'll want to gain 4 electrons by sharing electrons. Right? Nitrogen. Sorry, my screen went crazy there. So nitrogen, if we look at nitrogen next to it, has 1, 2, 3, 4, 5 valence electrons. So it needs to share 3. So it needs to either share 3 or it needs to take 3. So it will tend to form a 3 negative charge because it needs to get to 8. It wants to be stable like the noble gases, right? Because it needs 1, 3 more to be stable. Oxygen, right, has 6. 1, 2, 3, 4, 5, 6. So again, it needs 1, 2. It needs 2 more to get to 8. So it will either share 2 or it'll take 2. So it tends to form ions with a 2 negative charge. And chlorine is our last one. And it's in group 7, so it has 1, 2, 3, 4, 5, 6, 7. Right? And it needs 1. So it will either share 1 or it'll take 1. So it tends to form ions with a 1 negative charge. And so does everything in that group that's a nonmetal. Okay? Alright, so coming to the end here. You have 3 main types of bonds. You have ionic bonds. So ionic bonds, electrons are transferred. Creating ions. You have covalent bonds, where electrons are shared. Right? This is most of you. So you're mostly all covalent bonds. And we have metallic bonds. Right? These are bonds between metals. And you have no metallic bonds in you. So you're made almost exclusively of covalent bonds, and you have some ions floating around you to give you charge. Okay, so let's just go over it again. We already talked about it. So if I take sodium and bring it next to chlorine, so these outermost electrons are my valence electrons. You'll notice that chlorine, or sodium, has 1 valence electron. So if we come back to our periodic table, sodium was in group 1, and it had 1 valence electron. Chlorine has 1, 2, 3, 4, 5, 6, 7. We came back to our periodic table. We looked at chlorine here. In group 7, it has 7 valence electrons. So sodium can become stable if it just loses that 1, because then its next energy shell here is full, and chlorine just needs 1 to be full, right? So this, when sodium transfers, remember, it'll be sodium positive, and chlorine, when it gains 1, will be negative, forming sodium chloride, which is neutral, right? Because this positive will cancel out the negative, right? And this is called electrostatic attraction. All right, so let's look at in a polar or in a covalent bond, remember, a covalent bond, electrons are shared. So if we look at it, oxygen has 6, so I'm going to come back here, I'll come back down. Oxygen, remember, is in group 6, so it has 6 valence electrons. So those are in the outer shell. So if I look at the green one, 1, 2, 3, 4, 5, 6. So I look at the yellow one, 1, 2, 3, 4, 5, 6. So remember, oxygen needs 2 more to get to 8. So if it shares, right, so if it shares, each oxygen gets to claim the electron of the other, right? So now I'll have 2 oxygens, and they're sharing 4 electrons between them. Two of these electrons are from this oxygen, and 2 are from this oxygen, right? So 2, 4, 6. Oh, sorry, I wrote that wrong. There we go. That makes sense. All right. So 2, 4, 6, 8. 2, 4, 6, 8. So now they both have 8, and it's stable. So this is nonpolar because oxygen, each oxygen is just as strong as the other. So electronegativity, you may hear in another video, is the ability to attract an electron. The most electronegative atoms in the periodic table are nitrogen, oxygen, and fluorine. This group right here. So they pull electrons the hardest, right? We don't really have fluorine in our body. We use fluoride for killing bacteria in our teeth, right? But we don't really have fluorine because it's too electronegative. So oxygen is another big one. So a polar covalent bond is where electrons are shared unequally, creating charge. So if you looked at our periodic table again, I'll come right back up here and I'll come right back down. So oxygen, right here, is very electronegative. And hydrogen, over here, which is grouped with a metal, but it's the only non-metal in the metals, right, is very not electronegative. So in the original periodic tables, by the way, they put hydrogen right here, right, because it just doesn't fit, right? But in our current periodic table, we put it over there with the metals because it has 1 valence electron, right? So oxygen is very electronegative, or it attracts electrons very strongly, and hydrogen doesn't, so we put it over there. So when we put them together, so oxygen is not strong enough to take the electron from hydrogen, it just can hold it right next to it, right? Which gives it a partial negative charge, right? And each hydrogen will have a partial positive charge. Now the oxygen will have 2 unpaired electrons up there. So it actually has 2 areas of negative charge, and it ends up having 2 positive charge. So if we draw it like the Lewis, right? So oxygen has 1, 2, 3, 4, 5, 6 valence electrons. Hydrogen has 1 valence electron, and they're shared between them. But we'll do this in chemistry. We'll point an arrow this way to tell the direction that the electrons are being held, right? So this makes it very this makes this positive, and this negative, this positive, and this negative. And what gives water all its unique properties, right? It's very polar. If I bring another water next to it, right, and I have a negative charge here, it'll connect to itself electrostatically like an ion would, and this we're going to learn over the weekend. It's called hydrogen bonding. And hydrogen bonding is very important to living organisms because we're all water-based. All right, so long lecture today. Sorry about that, but hopefully this helps you out, and I'll talk to you soon.